In this video, we want to look at rate of change. And so in the billionth app activity, we had to come up with an approximate or a average rate of downloads every second or every minute. And then we also had to figure out how much further we needed to go from either the last value that was given in the screenshots or perhaps the last value that was given in the video, and see how much further that was until we got to the 25 billionth so that we can figure out approximately how long it was going to take to get there. So we're going to look at that, and that was a use of the rate of change, and so we're going to more clearly define that in this activity. So first thing we want to do is define the input and output variables. It's vitally important that we do this every time so that we know which one is our input and which one is our output. The other thing we want to do is make sure that what we're talking about here is going to be a function, because although rate of change can be found if it's not a function, we're going to specifically be looking at things that are functions from this point forward. So if we look at, we can examine the graph, we can read what's going on to determine that the input and the output are such that the input is the years, and I'm going to just highlight it down here. The output is going to be the percentage, and so we can state that the input is y equal years from 02 through 14, and the output is the percent of Americans. Okay, so this does represent a function because for each year there is a unique percentage for either the increasing influence, or if we look at this graph, there's a unique percentage for losing influence. So now we want to calculate the value for losing influence in 2010. So that means I want to know a percentage at an input value of 2010. So if I look here, and we were talking about losing influence, so essentially what I'm looking for is that spot right there. So not really an input value, so we're looking for that spot right there, and we want to calculate this. So we're not using the graph to approximate it, we're actually going to calculate this. So the first thing I want to do is I want to figure out what is the percentage increase or decrease, and since this is an increasing graph, then I know that it's a percentage increase over that specific time period. So I know that I'm going to go from 52% up to 72%, and I'm doing this over a 12-year period. So if I calculate that, I know that that is a 20% increase over 12 years. So that in fact is a rate of change. And but because we're doing this in 12-year segments rather than say 1-year segments or 2-year segments, this is going to be difficult to find year 10 because we're not quite working it in terms of a 12-year segment means that we'd either have to decrease our amount from 72, we'd have to go back 4 years if I use my 72%, or I would have to go forward 8 years if I was starting with my 52%. And it doesn't matter which one we're doing because we're actually assuming, so in part D, we're assuming the rate of change is constant, even though our graph indicates that it is clearly not, because we notice it's up at a faster rate here, then it actually goes down here, and then it goes up significantly here. So we know that the rate of change is not constant, but we're going to assume this so we can actually calculate what this happens to be. And so there are several different ways we can go about doing this, but probably the general way is to try and find a 1-year increment. So that means if this happens in 12 years and I want a 1-year increment, so in 12 years it's 20%, so in 1 year it's going to be a 1.66%, or 1 2/3%. Oops. So 1.66 or 1 2/3% increase each year. Another way we can also look at this, since we're talking about 8 years and 4 years, maybe we would want a 4-year. So if this was 4 years, if we wanted a 4-year increment, that means the relationship between 12 and 4 years would mean that we would have to divide by 3, and then so we'd also have to take the 20 and divide that by 3, and when we take 20 divided by 3, we're going to end up with this 6 2/3% increase. So we can do it as a 1-year, we can do it as a 4-year, we can do it as a 2-year. We want to do it in some way that we can find some sort of comparable rate of change, because we know that it's an increase of 20% over 12 years. So now that we have this, if I'm going to go back 4 years, and if I'm thinking about it 4 years, so I'm simply going to take 72 minus 6 2/3%, which means that I'm going to end up with 65.3%. Or if I want to think of it as 8 years forward, I'm going to do 52 plus 2 times 6 2/3, or simply add 6 2/3 twice to the 52. And so that's going to leave us with 65 and 1 1/3, or 65.3. Notice it doesn't matter whether we're going back the 4 years or going forward 8 years. It's very similar to what you did in the billionth app. In the last rate of change, we did indicate that our assumption was that the rate of change is constant. When you calculate it for the increase in influence, you should get this value. As you see, your graph is going downward, so the rate of change is negative. So we want to state the meaning of this rate of change. So we found it to be this value, and it's clearly labeled, so make sure that you're always looking at labeling your work. And so when we label our answer, we're talking about the units of measurement, which is this piece right here. And so now we want to state what this means. So assuming that the rate remains constant, each year the percent of Americans that feel religion is losing influence or is increasing influence, pardon me, is decreasing, because this value is negative, by 1.25%. So the each year is this piece right here in terms of per year, and then decreasing because our rate of change is negative, and then our percent is 1.25%. We know that this is not constant, so we have to state that it is the assumption that this remains constant.